Okay, gentlemen, today is our first day using this strategy. So the intention here is so that you can review this video for homework, understand what the concepts that we're studying are, and then the next day put them into practice by doing practice questions. And that way you'll have more time to work on the practice questions, and I'll be there to help you, and you can help each other as well. So a lot more time to work on what you would traditionally do as homework, and now we'll do that in class together, and you'll have less homework at home because you're just going to be watching this video and following along. So let's get started. Today's lesson is 6.1 day 1, slope y-intercept form. So we're still dealing with linear equations. Okay, so this is a get your math juices flowing. It's a bit of a blast from the past. We are looking at solving for x here. Now, if you take a look at this first question, 1 over x, or 1 divided by x, equal 3. That's the same thing as saying 1 over x equal 3 over 1. In this case, we want to remember to use cross. That didn't work out well. Okay, cross multiplication. And that tells us we can multiply x times 3 and 1 times 1. So x times 3 is 3x and 1 times 1 is 1. And now we want to divide both sides of the equation by 3, and this way isolating our x. So 3 divided by 3 we know is 1. 3 divided by 3 is 1, so we're left with technically 1x, but we don't write the 1 here in front because that's not good form. So x equal 1/3, and that's our final answer. We're going to apply the same strategy here, but I guess you could say what's bothering us, or what is impeding us from doing this as simply as question A, is that we've got two denominators here. And so now it's not so easy as just cross multiplying. We can't simply cross multiply like this because we have an additional term. So on the right side of the equation, we technically have a binomial, right? So in this case, we have a binomial. There are two terms here, one term here. So how do we create a linear equation out of this? Well, the easiest way of doing that is to multiply every term in this equation by the common denominator. And the lowest common denominator, or the lowest common multiple between 4, 6, and the imaginary one that's over here is 12. So we're going to multiply every term by 12. I'm just going to enlarge that to make life a little easier. So that's being multiplied by 12. The 1/6 is being multiplied by 12. And the x is being multiplied by 12. And you remember when you multiply fractions, so if I could just get you to look at this part right here, that's really saying 12 over 1, 12 divided by 1 times x over 4. Now we could do 12 times x, which is 12x, over 1 times 4, which is 4, and then you'd end up with 12 divided by 4 is 3, and you'd have the x. That's one way of looking at that. However, what we're really doing is to save ourselves that. If we have 12 over 1 times x divided by 4, what we're really going to do is we're just going to cross reduce. 4 divided by 4 is 1, and 12 divided by 4 is 3. And then 3 times x is 3x, and the denominator is 1 times 1, which is 1. So really it's just 3x. So there's two ways of looking at it. Okay? And so again, 12 divided by 4 divided by 4 is 1, and 12 divided by 4 is 3. So we're left with 3 times x, or 3x, equal, in this case you have 12 divided by 6 because 12 times 1 is 12, and you have 6 in the denominator, and if we cross reduce, we get 2, and then plus 12 times x, which is 12x. So in this case, we are not doing cross multiplication, but rather cross reducing. Now we have a linear equation. We want to have our x's on the same side. So in this case, we have, let's put the x's on the right. You know what, let's get them on the left side, why not? So we're going to subtract 12x from both sides, and that gives us 3x minus 12x equal 2. Okay, now keep in mind, for some of you, I know you're thinking, hey, I take the positive 12x, bring it to the other side, and it becomes a negative 12x. You can think of it that way, just as long as you know what we're really doing is we're subtracting 12x from both the right side of the equation and the left side of the equation. So now I have 3x minus 12x, and that's negative 10x. Sorry, I apologize. Negative 9x equal 2, and then we want to divide both sides by negative 9, and we get x equal negative 2 over 9. And that's our answer for that. Okay. So the learning goals here are to write an equation of a line in y equal mx plus b format, or slope y-intercept form, to write the equation of a horizontal line, and also a vertical line. So we have a couple of exceptional cases. The vertical and horizontal lines are exceptional cases. So in this case, we want to look at, let's take a look at a horizontal line for A. We've got a handout. We can fill the rest of this handout here to create the equation. So the slope, if we have a horizontal line literally going left to right, think of it as a roof. There is such thing as a flat roof, and in that case, the roof is not sloping in any direction. It's literally a zero slope. If that's the case, then this slope is a 0. The y-intercept, you can tell what the y-intercept is because it's right there. It's at 2 or positive 2. Therefore, if it has a 0 slope, and we're writing the equation y equal mx plus b. I'll backtrack for a second here. M is our slope, and b is, you're going to substitute b for the y-intercept, or where the line crosses the y-axis, known as the y-intercept. I'll just do for short form y-int. Okay, and x and y, of course, are just coordinates. So if you want to find the value for the dependent variable, which is y, the value of the dependent variable is, as we said in class, a constant multiple, right? So the slope is being multiplied, or x is multiplied by a constant. So x is being multiplied by m in this case, which is the slope. So a constant multiple of the independent variable plus a constant. In that case, you have the y value is equal to a constant multiple of the independent variable, which is x, plus a constant. Now, if it's direct variation, we know that this part here won't exist. It'll just be y equal mx because there is no y-intercept. If it's direct variation, it passes through 0, 0. Okay. So the equation of this line is technically y equal, well, the slope is 0, and so if we multiply 0 times x, and then say the y-intercept is 2, y equal mx plus b in this case, well, 0 times x is 0. So we really don't want to write that because it doesn't exist. So the proper way of writing this is y equal 2, because 0 times x is 0. So in this case, y equal 2. A vertical line for b here, a vertical line is also an exceptional case. You have this line right here passing through negative 3 on the x-axis. Now, one way to understand this, and we talked about this in class, is thinking about it as a roof. So you could have, and I'll scroll down here to help you out, you could have a building that has a slanted roof. We'll do a little door and window. You could have a slanted roof or a sloped roof, and you could even have a building with a flat roof with 0 slope, but you couldn't really make a building with a vertical, there's no place to put my door here, I guess you could say. How are you supposed to make a building with a vertical roof? So even if we did something like this, and there's our door and a window, this portion right here is not really a roof, it's a wall. And so you can't really have a completely vertical roof. You'd call it a wall. So in this case, when it's a vertical line, we say the slope, or m, is undefined because you have rise but no run. So if you looked at slope as rise over run, let's just say the rise is 5 and the run is 0. If you think about this as a test mark, how are you supposed to get 5 marks out of on a test that's out of 0? doesn't make any sense. But if in this case, if it were a 0 out of 5, you could say you got 0 on a test. It's out of 5, but you've got 0. And that would be a 0 slope. But when you have numerator and a 0 denominator, then that's undefined, or it's undefined. So that's just a little visual to help you understand what's going on. In this case, for B, we have a vertical line passing through, again, -3 on the x-axis. And in this case, so the slope is undefined. I'll just do UND for short. The y-intercept, it doesn't touch the y-axis. It's running completely vertical. This line is parallel to the y-axis and will never touch the y-axis, again, because they're parallel. So in this case, there is none. There is no y-intercept. So the equation here is unique as well, and it's x equal -3. So one way to understand that is that on this line in B, the line will always have an x value of -3. It will never touch the y-axis, but the x value is always -3. So that's one way of thinking about that. Let's try it again with C. I apologize, C is kind of hidden here on the handout. On your handout it should be clear, but on my handout it's kind of disappeared. But I can tell that this line is a vertical line passing through 4. So let me just use some space down here. We've got 1, 2, 3, 4 is where that line is passing through. It's a vertical line, okay? And in this case, again, the slope is undefined, and the y-intercept, there is none. In this case, it's x equal +4. That's our equation. So let's fill that in here. X equal 4. The y-intercept, there is none. And let me just correct that. None. And the slope is undefined. Taking a look at D, we have a horizontal line again. In this case, the horizontal line is right on the x-axis. That's pretty interesting. We have our slope is 0 because it's running completely horizontal. The y-intercept is technically 0, and the equation is y equal 0. And that means it's running along the x-axis. Okay, again, if you had y equal 0 slope times x plus the y-intercept of 0, really you have y equals 0 plus 0, which is 0. And that's one way of getting that equation. Let's look at E now. Sorry, E's up here. So here we can see the y-intercept is given to us here. It's +3. And we're also given a point right here with that given by that dot. And that's 2, -1. So we've got two coordinates that we can see. We've got 0, 3, and we've got 2, -1. There are two coordinates there. So if we want to calculate, so 0, 3, and 2, -1. If we want to calculate the slope, we can simply, let me just erase, that's all right, I'll leave that there for you. We know the equation for slope is m equals y2 minus y1, or change in y, and x2 minus x1, or which means change in x. In this case, again, 0, 3, and 2, -1. I don't need to scroll up for that. We have 0, 3, and 2, -1 as our coordinates. So let's say y2 is -1. We'll call that y2, and that'll be y1. So y2, and I'll call that y1. So -1 subtract 3 over x2 minus x1, and that'll be 2 minus 0. In this case, we have -1 minus 3, which is -4. Just for those who aren't familiar with their integers, -1 minus 3. When you have -1 minus 3 and you have subtraction of integers, the rule that we use is change subtraction to addition and change the following integer to its opposite. So it's a +3 becomes negative. Now you have -1 plus a -3, which in this case is -4. That's why I got the -4 there. So -1 minus 3 is -4 over 2 minus 0, which is 2, and our slope is -2, because -4 divided by 2 is -2. All right. So our slope for E is negative 2. And the y-intercept we know is 3 because it was given to us in this coordinate right here, which is right there. The y-intercept is positive 3. So if we know the slope is negative 2 and the y-intercept is 3, then y equals mx plus b, and in this case plus b is 3. Again, b could be a negative value as well. F, looking at slope here, we have the y-intercept given to us. It's negative 2, so we can go ahead and fill in the y-intercept as negative 2 right away. All we're missing is the slope. We know we're going to write y equals something x plus b, and the slope, we already know the y-intercept is negative 2, so we can fill that in. We're just looking for the slope to go in front of the x here. So to figure out the slope, let's look at two coordinates. We know 0, negative 2, which I've already marked here as a coordinate, and we know 4, negative 1 is also a coordinate. So let's go down here and say slope equal y2 minus y1 over x2 minus x1. And we had 0, negative 2, and we also had 4, negative 1. So y2 is negative 1 minus negative 2, and x2 minus x1 is 4 minus 0. Now, as I mentioned in class, as you become more sophisticated in your math, you'll realize that you have, for y2 minus y1, you have negative 1 minus negative 2, or subtract negative 2. When you have that, we know that the rule is change subtraction to addition and the following integer to its opposite. So we really have negative 1 plus positive 2, which is negative 1 plus 2 over 4 minus 0, which is 4. So as you get more comfortable, I would expect that you would be writing negative 1 plus 2, and you'd skip this step altogether. So negative 1 plus 2 is 1, and the denominator is 4. That's your slope. So the slope is 1/4. Let's scroll back up here. 1/4. In this case, you have y equal 1/4 x minus 2. All right, I hope that helps, and we'll see you in class ready to go to hit the textbook. Have a great night.